Good morning, Michael. I'm here with Hal Getzelman, the lead Capcom, and we're excited to join you today.
Oh, thank you very much. We've got Clark Creek STEM Academy in Ackworth, Georgia, so they would love to speak with you and ask you lots of awesome questions.
Great, we're ready.
Excellent. Guys, I might ask you to come up here so that we can...
So go ahead with your first question.
Go ahead, Rosedaris.
How do the astronauts stay in touch with their families while on ISS?
Can you help me with that one? I didn't hear.
Mike, I'm sorry, can we have her repeat that?
How do the astronauts stay in touch with their families while on ISS?
Families on. I think your question was how do the crew stay in touch with their families in space? And they have several ways to do that. First, they have email, and they're able to send and receive email. The second method they use is they actually have conferences set up on a weekly basis, and those are a way that they can actually watch their families on TV up on board, and the families can watch them on station. So they have two-way video and voice and talk about whatever they want. Sometimes these conversations are as quick as 15 minutes. Sometimes they'll go on for an hour.
Okay. Mr. Hare, we're not seeing mission control.
Okay, we'll go ahead and switch it so it'll be forced over so you can see it. Definitely have the children come up and speak loudly and clearly for the next one, but great first question.
Okay, go ahead.
Okay. Is there a constant audio connection with the ISS? Do their voices change while traveling through space?
There is not a constant connection. Our satellite connection, we start here in Houston, and we have a fiber optic link that goes out to White Sands, New Mexico, that connects into an uplink station that bounces off one of the TDRS satellites and then connects to the station. So when we're in sight of those satellites and when the station is able to communicate through those satellites. So we just a moment ago we had a 10-minute loss of signal, and we lose both our telemetry and our ability to communicate with the space station for that time period. On a typical orbit of 90 minutes, you can expect that we will have about say 80 minutes or 50 minutes, 50 to 80 minutes of communication available.
Okay, good. We're still not seeing mission control. I don't know if there's something on your end that you need to switch the screen.
Okay, we'll check into it. What are you currently seeing at the moment?
You still.
Okay.
Yeah.
Okay, well, we will switch it
Okay.
over so that you can
Okay.
see a live view inside Mission Control. So go ahead with your third
Okay.
question.
Okay, go ahead.
Describe your educational background.
Okay, well, like most of you, started out in grade school and went to high school. I studied a lot of math and science. I was pretty good in those subjects. After graduation from high school, I went on to the Air Force Academy in Colorado Springs. From there, I received a Bachelor of Science in Mechanical Engineering. I went on to pilot training and flew in the Air Force for about 20 years. During that 20 years, I also went to the Air Force Institute of Technology and got a graduate degree in space operations. So that's my academic credentials, plus a lot of training along the way in the Air Force and here at NASA.
Why were you awarded the Bear Award?
Well, the Bear Award is an award from the Barrios Corporation, one of our private contractors that supports the space program down here. And that was their top employee for that year. So that was the award that was presented to me.
Go ahead.
How did various technology get selected to work with NASA?
Mike, can we get them to repeat that last question? I just got parts of it.
How did various technology get selected with
selected to work with NASA?
Okay, I'm still having trouble understanding the thrust of your question. I heard the word technology, but I didn't hear the rest of the question.
How did Barrios Technology get selected to work with NASA?
Ah, thank you very much. Barrios Technology, like many of our private contractors, competes. So NASA will announce a certain amount of work that they want private contractors to perform. And then Barrios Technology will go ahead and submit a proposal with costs and a number of people. And then NASA will have a review panel to look at all the proposals and select the best qualified corporation. Sometimes Barrios wins these contracts, sometimes they don't. Our main contractor here is United Space Alliance, and they, as well as Lockheed Martin and a few others that perform work for NASA.
Might the ISS be open to privatized commercial space travel? If so, how do you feel about this?
Well, I think it's a big plus for America, and the reason I say this is at one time NASA did a lot of aeronautics development and research and actual building airplanes, and now we see that NASA in the aeronautics still does a lot of technology demonstrations and prototypes, but the work of actually developing commercial airplanes or military aircraft is turned over to private manufacturers under the auspices of the federal government. So in a similar vein, in the space business, we're seeing more and more of the space business being a solely government operation into being a government and private cooperation. So I think it's good.
Go ahead.
What was the situation that you recall that required the most problem solving on the part of the astronauts?
Okay, well, we have a lot of equipment on the space station, and a lot of things break from time to time, and we form investigation teams that help solve those problems. So, you know, in our business here, it's a lot of collaboration. So it's not typically where one person comes up with the brilliant insight to fix something or to work around something, but rather a group of individuals that work together as a team that know different aspects of the problem, and they put that all together to come up with a solution. So if you say the best one, I think the best part was I got to be on the execution team where we got to repair a torn solar array, which involved a very dramatic EVA and some unique hardware that was designed pretty much on the fly, and that was a lot of fun.
Go ahead, Ellen.
What are some situations that have emergency procedures?
Well, that's a great question. You know, probably in school there today you have fire drills, right? And so you practice going outside and getting away from a burning building and making sure everybody gets out safely. Well, we do the same thing on space station. We have a possibility of fire. Hopefully we've worked to minimize that. We work with chemicals and research things where it may produce some toxic vapors, and also we have a problem you don't have on the ground, and that is we live inside a pressurized can, and if that can should spring a leak, that module will go to vacuum. So our three big worries are rapid depressurization, a toxic release, and a fire.
How can students submit their experiments to the ISS?
Well, that's one of the areas I'm not as familiar with as probably I should, but we do have a payloads operations center in Huntsville, Alabama. They reach out to universities and to students around the world to help them in the process of getting their payloads on orbit. But a very good question, because that's what the space station is all about, is doing research in orbit.
What advice can you give me if I wanted to become a NASA engineer?
Well, the advice I would give you, and that's a good question because I was faced with that same challenge when I was your age. What do I need to do? I think the most important thing is to do the best job you can in your academics today. Give it your best effort. You know, your teachers aren't there just to spoon feed you information. They're to help you in your education journey. So it's mostly on your shoulders to study hard, to do your homework, and to find those areas that you really like doing. Because if you really enjoy doing something, you're going to do a very good job at it. So I think in the space business, those areas that are most important are math and science.
Yeah. How did you work your way up to be the chief engineer?
Well, kind of continuing on, that's a good question. You know, continuing on, a lot of people look at the jobs that I've done and said, well, you know, if I do those same things, I will get to the same place. And that's not necessarily so, because we like a lot of different people and what they bring to the equation. I think the key thing is to whatever job you're given, do the best you can at it. In my case, I took a path through the Air Force and flying airplanes. And eventually, after I retired, my background was very useful down here, working with procedures and working with displays and aerospace machinery. Those skills helped me a lot in this job.
No, Brianna.
Does anything in space cause interference on the Capcom console?
Well, yes, there are certain interference problems. You know, we do have a lot of electronic equipment on board, and we're constantly trying to minimize and control what kind of problems that might cause. In space, we have radiation, and we have solar flares, and we have a Van Allen radiation belt. And sometimes those charged particles cause problems for our electronics.
Okay, great. I am going to hang up. I've been advised to hang up and dial in so that we can maybe actually see mission control. So I'm going to hang up now and dial back in.
Sounds great. We'll wait for you when you come back.
Okay, thank you. Oh, yes, sir.
And this is Michael Hare at the Digital Learning Network. Mr. Getzelman, I hope you don't mind, but I actually have a question for you.
Yeah, go ahead.
I was just wondering, normally throughout the history of human spaceflight, it's normally been astronauts that actually get the responsibility of being a Capcom or a capsule communicator. I understand with the International Space Station, you're 24/7 operations, 365 days a year. And we've been doing it since the year 2000. So I could see how it opens up. But how did you get the opportunity to actually be a Capcom amongst those elite astronauts?
Well, like you, I saw the scheduling challenge that would be, and I realized that we didn't actually have enough astronauts to conduct Capcom duties 365 days a year and 3 shifts. We now have scaled back to smaller shifts. So I knew they were going to have to change their policy, and I tried to make myself as qualified as possible. And then we had a gal named Ginger Carrick, who is one of our senior flight directors now, but she had spent a lot of time training with the first expedition crew, and she demonstrated that with the right training and the right background, you could be very effective as a Capcom, even though you weren't a astronaut.
All right, excellent. Looks like Clark Creek STEM Academy is back, and I think they're able to see you. So let's go ahead with your next question.
Yeah, go ahead.
Do you have security measures to protect secret information?
You know, that's a interesting question. I know we're all concerned about secrets, but in my case, I don't deal a lot with secret information. There's other people on console who have that responsibility, but I really don't. You have to understand everything I say that goes on the radio is transmitted worldwide, so it's probably best I don't know too many secrets.
Go ahead, Destiny.
What does it take to be an effective leader?
Well, I think the first thing is competency, knowing your job and being very good at it, because people are going to look up to you as a role model. So the first thing is knowing what you want to do. And then the second thing is to know the people that are working for you and to know their strengths and weaknesses and figure out how to use those to best advantage to your organization's objectives. So I think that's the two aspects, being very competent and knowing how to interact with other people.
Do you ever share jokes or humorous stories with the ISS astronauts?
Yes, I do, especially if I know them personally. We do some gentle ribbing or ridicule, maybe a little joke, but I try to keep it under control because, everybody else who listens in on the open space groups, they may not understand the jokes and they may not think they're quite as funny as I do or the crew does. So I have to make sure that I do it in a professional way.
What kind of software does Capcom use to communicate with the ISS?
Okay, well, we use several means. Obviously, we use the voice through our satellite links to communicate. We also have email, and we process the email. We kind of are a filter to make sure the crew doesn't get too much junk email like we all hate at home. We also have video so we can watch the crew as they're performing their work, and it's really amazing if you can actually see what's going on, how much that helps you understand where the crew is in their days, activities, and all that.
You are noted to be a cheerful leader for ISS Capcom. How do you manage this?
I think you said cheerful leader. So I think if you have a smile on your face while you're working and you're happy to do that work, I think that comes through on the radio. And I'm very happy to be doing this job. I think everyone wants a job where they feel that they make a difference. And I think when I'm working here as a Capcom, I'm making a difference to space exploration. So that's really fun.
How do you make sure the astronauts have the supplies they need?
Oh, okay. I think you're asking about supplies. And as a Capcom, I don't really play a primary role in that. We do have an inventory stowage officer, and they have a computer database that keeps track of all the equipment and all of the items on board. And they see how the food is going and how much water we have stockpiled, and they make sure that the next resupply mission that comes up brings more of the stuff we're getting low on. But as a Capcom, I don't particularly manage that.
Yeah. What is your favorite academic subject and why?
Well, I like both math and science, and I like math because there's always a right and a wrong answer. And if you do your work hard, you can find that right or wrong answer. It's not a maybe kind of thing, or it's how you feel. So I like math because you can finally feel like you accomplished something. Science, I like that because it's pushing out the boundaries. You think of the struggle of man throughout the centuries. What a fortunate time we live in with the access to the internet and our textbooks and our teachers to learn so much more than people did, say, even 50 or 100 years ago. So science is very exciting because we're constantly pushing out the knowledge, the frontier of knowledge.
What do you recall as the most difficult episode while acting as the liaison between Mission Control and the ISS astronauts?
Well, I think, I talked earlier about repairing the solar array that tore while it was being relocated and then deployed. And without that solar array being, if you will, secured, it would affect whether we could rotate the solar arrays or not, and that would compromise some of our power generation. So I think being able to, as a team, pull together a plan and then executing that plan on orbit was probably one of the most amazing things we were able to do here in the recent past of the space station deployment.
Might you visit the ISS? Why or why not?
Well, unfortunately, I think I'm getting a little too old to be picked to be an astronaut. And so, like you, I'd like to go, I think. But right now, I'm thinking I have to win the lottery. So when the lottery gets up above 30 million, I buy a few tickets and hope for the best.
That's good, go.
Okay. What do you see as the ISS legacy?
I'm sorry, can you repeat the last part of that question?
What do you see as the ISS legacy?
Well, I think the legacy of ISS is going to be, one, the difficulty of assembling it and building it and designing it. And I think those lessons will be used again as we go further out into the solar system. The second lesson, I think, is the research on human adaptation to weightlessness and the environment of space, so that when we do go to the moon or Mars again, or even to an asteroid, we'll have a lot of data to work with, a lot of understanding of what happens to folks who are inside a small enclosed environment for a long time. And then I think the third thing is going to be the research that we do, and that research as it gets reapplied to products and services on the ground. So I think those are three areas I'm looking forward to as we move forward in this century.
What is the role of the Huntsville, Alabama counterpart in Capcom ISS events?
Yeah, Huntsville is our payload operations control center, and they have a PACOM as well who communicates with the crew and talks to them about the science and the payloads they're doing on orbit. So we primarily in Houston worry about the actual systems and hardware of the space station and provide the services to the payloads folks. So they worry about the payloads, the experiments, the science, and we worry more about the vehicle and its operation, visiting vehicles, cargo ships, those kinds of things. We also have other control centers, one in Munich that works with the European Space Agency and their experiments, and Scuba Japan, their JCOM, also works with their Japanese science and experiments. And finally, we have the Russian Glavny, who has a similar role of communicating with the space station about their people.
All right, and we have about a minute and a half, so one final question from Clark Creek.
Are we dependent upon the Russians to deliver astronauts to the ISS? If so, is this a problem?
At the current time, our only way of getting astronauts on board is using the Russian Soyuz vehicle. We are continuing to develop U.S., both private companies and NASA government vehicles that will be able to reach the space station. Until those vehicles are operational, we will rely on them. Now, this is a partnership, and so we have the luxury of relying on the Russians for their transportation. But I think everybody here at NASA would like eventually to have our own vehicle and also to open that business up to the private sector.
And we should mention what Hal was referring to was the spacecraft that can transport the crews, but we do have other vehicles, including the newly designed Dragon, that can bring up cargo. So we don't have to rely on the Russians for other supplies. There's other vehicles, including the ATV and the Dragon spacecraft that's going to launch on March 1st. So there are other vehicles as well. Thanks again, Mike, for setting this up. We really enjoyed talking to the students.
Thank you so much. Thank you. Very nice. Thank you.